Okay, so we're going to go over the second half of the practice test. There's a bunch of stuff I emailed you about where there's like extra stuff. 4 of the PDFs have been up the whole time. One of the bonus question from the quiz came directly from one of the PDFs. There's some more questions uploaded. I'm going to hand back the worksheets that you guys did last week. I'm not going to grade them because the solutions are online. I just wanted you to be busy and like try out some problems. But they're good problems for you to go over again. So I'll give that out before the end of the class. Test Thursday means there's 2 assignments that are due. Hopefully you've had enough time to finish them. If you have extended time before you leave today, let's discuss when you're going to use it. And if you are going to forfeit your time, you need to tell me that so I can email you and confirm, because I'm not about to get in trouble for you not using your extra time when I'm offering it. Okay, so let's do number 10. Do we have any idea how to do this so far? Do you want to try it first or just go at it?
Go at it.
All right, let's go at it. Perfect. So find d squared y dx squared of x minus cosine y equals y by implicit differentiation. Okay, a couple things to note. We have y inside a function. So implicit, when we take the derivative, we're going to have to multiply by dy dx, aka y prime. Also, it doesn't just want the first derivative, we're trying to find the second derivative. Cool.
So you find the first derivative first.
So let's find the first derivative. So I'm going to dx this whole thing. X minus cosine y equals d dx of y. So this whole d dx with the parentheses, that's a verb. It's telling you take the derivative. That's what d dx means. It's the math verb saying take the derivative. So derivative of x is just 1 minus derivative of cosine, negative sine y times y prime equals y prime, because the derivative of y is 1 times y prime. Okay, cool.
Put all the y prime there.
So I'm gonna have 1 plus, because minusing a negative, add it, 1 plus sine y times y prime. I'm just gonna like rewrite it so it's nice and neat. Sine of y times y prime equals y prime. So right, we want to get all the y primes on the same side, so I'm going to subtract sine y times y prime. So I have 1 equals y prime minus sine of y times y prime. So we need to get y prime by itself. It's a common factor in both these terms, so I can pull it out. Do you understand what I'm doing when I say pull it out? I'm literally dividing each of these terms by y prime. So that way I have 1 minus sine of y times y prime. So if I divide both sides by 1 minus sine of y, I see y prime is going to be 1 over 1 minus sine of y, aka I could rewrite this as 1 minus sine of y to the negative 1 power. Cool. We're halfway there. That's only the first derivative. Is that okay? Move it up a little bit. We're only halfway there. The problem wants the second derivative. But if you don't find the first derivative correctly, you're going to be screwed because it depends on the first derivative.
Wait, why do you put it in a fraction? Like, where does the to the negative 1 power?
If you have like 1 over x, this is the same thing as x to the negative 1.
I know, but where do you, like, it goes from like the parentheses, like 1 equals, and then because you're dividing.
Yeah, I'm dividing to get y by itself. I was just lazy because I didn't want it to be 1 over. I wanted the y prime on the left side, so I could write it. Yeah. Technically, I should have wrote it as like this. Yeah. Okay. That is the first derivative. We're trying to find the second derivative. Let's do this again. So I have y prime. Oh my god, why is it this way? Okay. Y prime equals, I'm going to leave it this way, 1 minus sine y to negative 1 power. So notice, like, I'm being very clear. Sine of y. Sine cannot just be by itself. You can't just have sine or like sine squared. This is a common mistake at least 3 of you are making. Like, it always has to be sine of something. sine squared of something. You have to have an angle. Sine is an operation. You can't just have like a random division sign. Like, what do you mean? Like, when you're dividing, you have to like have two terms. Well, when you're taking sine, like you have to have something inside of sine. Okay, beating a dead horse here. So let's go ahead and let's take the derivative of both sides. So let's dx this whole thing. So on the left side, this turns into d squared y dx squared, aka y double prime. Okay, we just have to be consistent with our notation. And this will be equal, ooh, we got to use chain rule. So the first thing we do is we have this negative 1 power. We got to bring it to the front because I have a function inside a function. Okay. Do you see how all of this is to the negative 1 power? Right. If you had like x to the negative 1, how would you use power rule? And then subtract 1. Exactly. So that's what we have to do up here. We have to bring the negative 1 down and then subtract 1.
That's just the power.
Yes. So because I have a function inside a bigger function. It's kind of like I have, oh my, why am I writing so big? It's kind of like I have x to the negative 1 power, but secretly we know x is equal to 1 minus sine of y, right? Instead of saying x, I would have 1 minus sine of y. So that's the whole idea of section 6, chapter 3, it's chain rule. And then I have to multiply by the derivative of whatever's inside. Let me make this a little smaller. The other day, I was such an idiot. I was grading someone's paper, and I tried to like zoom in, because I'm literally on here for like 5 hours a day. I was, There you go. There's your happiness of the day. There you go. Just laugh at me. Okay, so that's the outside. Now we gotta multiply by the derivative of the inside. So derivative of 1 is 0 minus derivative of sine y. Derivative of sine is cosine of y. Okay, cool. And then we have to multiply by. This is actually a function inside. So we have to multiply by y prime. Exactly. AKA dy dx. Whew, that's really messy looking. It's not pretty. So we can do a little makeover, simplify it a little bit. So this is going to be, okay, y double prime. Let's have negative. Let's see, so the 0 goes away. So I have negative, so I'll have a positive cosine y times y prime over 1 minus sine of y squared. Yeah. Right, because 0 minus negative cosine, 0 minus cosine y is just negative cosine y. So if I take this negative, multiply this negative, turns positive. So I have a cosine y times y prime, and then this, since it has a negative exponent, I moved it down. Okay, does that make sense how I got to this way? Yep, I can. Okay, so how did I simplify this? I saw 0 minus cosine y is just negative cosine y, so I crossed that out. So negative 1 times negative 1, that crosses out, right? Negative times negative goes away. So at the top, I have cosine y times y prime. And since right here is a negative exponent, I just dropped it below. I dropped this whole thing below the fraction bar to make it a positive exponent. Okay, yes?
On the test, would we see any sine squared y, like with cosine squared y and all that?
Ooh, that would have been a good one.
Like, no, but I don't know how to do that.
Okay.
So, how do we do that? If it's not going to be on there, just don't tell us.
I mean, you gotta know how to do it.
Credit, just can you tell us? Because I am beyond stressed.
Sometimes I think I'm too nice to you guys. Okay. You say no way? I am definitely nice, tall. Okay. Okay. This is a lot of color. It's fine. Okay. So let's finish this first. Let's finish this first, and then I can like. Do you want to like? I'll write it here. If I have time at the end, I'd like to go over that. That's a good question. So what if it was... Why don't we just make it easier? Let's just do that. There you go. We can figure it out.
I don't know how to figure that out.
Right, so we'll do this at the end.
Okay.
Just remind me, because I'll forget, because I'm turned around now. Okay, so we're not done, because, oh, wait, y prime, do we know what y prime equals?
Oh, we do know what.
Check it, y prime, y prime, okay. That's a lot of color, I apologize. But, it shows you cool stuff.
Like automatically put on the bottom.
Yes, but I want to make sure I don't lose anyone, so I'm going to write this as cosine y over 1 minus sine y squared times, well, y prime is 1 over 1 minus sine y. So that means y double prime, aka d squared y over dx squared, is just going to be cosine of y over 1 minus sine of y cubed. Woo, done, QED. So notice on the left side, y double prime means the same thing as d squared y over dx squared. Okay.
Wait a minute.
Yes.
Oh.
Okay. Do I need to zoom out at all? Are we okay? Okay. Anyone need more time to write? Okay, sure.
Can I skip this one?
Sure.
So
What one?
for the second one on the worksheet that you gave us in class,
Yeah.
what's the difference between like the colorful and the fish? Because I got like different answers.
For which one?
For the one that's like x squared over. Like it's 30 is spoken over, like we thought it's a negative 1 r, which is something. But that's negative 1 r, but it's x squared. So then there's if you go on, that's just one. Yeah, because yeah, because I did like because I squared times sides and then yeah, we're using these. Seven kills. So we only want number 2 times.
It's just one way is a little quicker. Okay, so that's enough time. I think you wrote it down, so we can keep going, yeah?
I have a question. Why on top for the second line, why you do y prime? Like where did it go? You have to because we found y prime earlier.
This is what y prime is.
You remember how the first oh.
I think you left the room when I was talking about this.
Yeah.
So that's the issue when people leave the room. Like, you missed what I said. That's why we have bathroom passes. Cool. Okay, so let's keep going. Number 11, find the slope of the line. Y equals ln of 1 minus x at the point x equals 2. So first, okay, we want the slope at a certain point. So what we need to do is take the derivative, because that gives me an equation of finding the slope at any point. Once I find the first derivative, I can plug in x equals 2 and find what the actual slope is. No, because we know the derivative of ln. Yeah, if you raise each power to e, then you're going to have to impose a differentiation. E to the y, you don't want to do that. So y equals ln, I'm just rewriting. So let's take the derivative of everything. The left side turns into dy dx, aka, this is my y prime, means the same thing. Also, f prime of x means the same thing. These are all acceptable forms of first derivative. If you write d prime, no, that's not at all correct. It has to be f prime of x, y prime, or dy dx. Those are 3 ways I'll accept. Otherwise, goodbye. Right side. So we know the derivative of ln of x is just 1 over x. Throw back to the first day of chapter 3. I gave you an equation sheet that said useful derivatives. It's a one sheet, front and back. There you go. Maybe check it out. All right. If I have ln of u, where u is a differentiable function, the derivative would be 1 over u times du dx, aka 1 over whatever you're taking ln of times the derivative of what's inside. So here I have 1 over what I'm taking, 1 over 1 minus x, because here u is equal to 1 minus x times the derivative, which is negative 1. All right, because derivative of 1 is 0. Sorry, let me show that. All right, derivative of 1 is 0. Derivative of negative x is just negative 1. 0 minus 1 is negative 1. So the derivative, y prime, is going to be negative 1 over 1 minus x. Cool. But wait, we want to find it at x equals 2. So if I evaluate at x equals 2, I have negative 1 over 1 minus 2. Negative 1 over negative 1. Oh my gosh, that's just 1. What are we trying to find? Slope. Yeah, we found slope. It's just the derivative at that point, evaluated. So the slope is 1. Done.
Oh, okay. So you don't want us to write it in the equation, right?
Did it say write an equation? No, it said find the slope. If I said find the equation of the tangent line, asking for a line, you have to write an equation of a line. Yep. Okay. Let's keep going. A particle moves along a line, so its position at any time t is greater than or equal to 0 is given by this equation. S of t equals 2 times t to the third minus 3 t to the second plus 3t, where s is measured in meters and t is in seconds. Find the average velocity of the first 2 seconds. Average velocity is literally the slope equation you learned in Algebra 1. y2 minus y1 over x2 minus x1. Yeah? It's just here, our y's are literally the function values. So s of 2 minus s of 0 over 2 minus 0. What? S is my, it's s of t, that's my function. Yeah, yep. So, parentheses, grouping symbols are your best friend. That way you don't miss distributing a negative. This is where you guys make your mistakes. Do you want me to say things like that? Tell you where you make mistakes so you better pay attention to it? I don't want to mark you off for like these small little things that you shouldn't be missing. Because it's like, it's not even the calculus. It's literally you not distributing a negative. Like, it makes me sad.
Velocity?
What?
When you say average velocity, you just have to know it's s of.
Average velocity, so here's position. This is your position equation.
Yeah.
So average velocity, it's your, where you start, where you end minus where you start over the change of time. Like change of position over change in time.
Well, where are you getting 2 and 0 from?
Because in the first 2 seconds, from 0 to 2 seconds.
Oh, that's the key. Okay.
All right, so let's plug in. So s of 2, so that's going to be 2 times 2 cubed minus 3 times 2 squared plus 3 times 2 minus, all of my t, every term has a t in it, so if I plug in 0, everything's minus 0. Wonderful. Over 2. So this is going to be 2 times 8, 16, 4 minus 12 plus 6, 22 minus 12 is 10 over 2, so that's 5. And since it gave us the units, we can say 5 meters per second. Okay, average velocity, slope-y-dope equation. Instantaneous velocity is at that moment, what's the slope?
So if you take the derivative.
Take the first derivative. And it says at any time, then just like leave it in terms of t. So s prime of t is going to be my equation for v of t. The first derivative of position is velocity. So s of t is equal to, so I'm just going to rewrite it. So it's here plus 3t. Okay. So if I take the derivative, s prime of t is going to be, let's see, 6t squared minus 6t plus 3. Cool. Is there a question about this one? Are we feeling comfortable about this one? Yeah. And then think to yourself, don't say it out loud yet, just in your brain, not vocal, just brain. How do I find acceleration from what I know. Turn to the person next to you and discuss. How do you find the acceleration now that we know the equation for velocity? Hey, say it louder, Ty. Yeah, second derivative of position, aka the first derivative of velocity. So acceleration is going to be the first derivative of velocity, or as Ty said, the second derivative of position. Perfect. So take what we just found, take the derivative. Kind of sucks. This problem depends on if you did 13 right. That's why there's a thing called carry-through error.
Some teachers don't do that.
And this is why I'm such a stickler for showing your work. Because if I'm going to be nice and spend this time to figure out your thought process, I need to be able to follow your thought process. I'm Hansel and Gretel. You got to give me crumbs. If I'm lost, good luck. I can't give you points. You like it? Okay, thank you. I said that earlier to my other classes, and that was like the most deadpan I've saw anyone. Because all 5 of my classes have a test Thursday. I didn't plan it that way.
Lots of
That's
grading.
a lot of grading.
Yeah, I know. Why'd I do this? Oh, because I'm nice. Because I'm like, oh, blessed be upon you, so you can study more. Okay. Okay, let's take the derivative. A of t, acceleration. Okay, so 12t minus 6. Oh, that wasn't hard. Okay.
You know you're doing this. This is really difficult.
Huh?
It's pretty simple.
It's just, like, once you understand, like, once you, like, get it, it's like, oh, it makes more sense. But if you're lost, no, you're going to want to cry. Of course, if you know you're doing it. Oh, what are we trying to do? Find acceleration at 3 seconds? So plug in 3 into the equation we just made. Once again, 13, like, you can't have 14 unless you found 13. You can't have 15 unless you, oh, the second 14, my bad. 15. Okay.
Do we have a calculator for this part of it?
Didn't I give you, this is, oh, yeah. I gave you a practice test, and it tells at the front.
But where's the, this is the no calculator stuff. So we have to be able to do 12 times 3 without a calculator?
Yes. Do you see what happens on number 16? What does it say on the top of the page, next page?
I know exactly. Hardest part for me.
It's all cool. It's all good. You can do this. I think you're just stressed. Understandable. But I've done all I can do. I can't move the test another day because it would be blackout. So, yep. Because instead, I move this test and then we'll have a day for chapter 1, chapter 2, first part of 3, second part of 3. Those are your 4 days of review for semester final. Huh? No. Surprise. I moved the test to today. It's not today. Thursday.
So we're going to be learning no more after this test?
Oh, no. You'll definitely be learning stuff as we review.
Wait, what?
Not like new material.
You guys will be being like, oh, I forgot this. You're going to have to relearn.
Okay.
Well, we did this
new
semester.
material.
Oh my god.
Not a lot of them.
If only I talked about this yesterday in the screencast.
But Monday, Tuesday is
Hey, I haven't watched it.
Okay, let's keep going. Let's keep going. Let's keep going.
Wait, Monday, Tuesday isn't markup.
It's not. Yeah, you're right. I could have had the test then.
No,
But
It's good where it is now.
what are we doing on Monday?
so Monday, reviewing chapter 1. Tuesday, reviewing chapter 2. Wednesday, first half of chapter 3. Thursday, second half of chapter 3. And then the next Tuesday is your final. 4 days of review for the final, which is about 2 days normal for calc and AB calc. Because, let's get that good test grade. Okay, ooh, what does this say? Calculator okay. This is the calculator okay portion. Yay! So don't forget your calculator for Thursday. What? Gives you joy?
No, I was saying
Oh.
Hannah's reactions from the semester. They animate the class.
You animate? She animates, yeah. It was definitely a different class without our 3 Tanzania girls. What? It was different. It's good. The questions you guys bring up is good.
On Instagram? 'Cause I did.
Huh?
Did you like and
Those
comment?
are awful photos.
Oh my God.
I look like 40 pounds bigger than I got
Okay, let's keep going. Let's keep going. Okay,
So I'll just send everyone an Even though they
guys,
large hunger.
tickety tock. Tick tock, tick tock. Come on, focus. I'm asking you nicely. Asking you, nice, tall. Keep it together. You're wasting my time, and you're wasting the time of the people who are paying attention and trying to get a good test grade. This is the last test grade of the semester. This could either make you or break you. There you go. There's more anxiety for you. Focus, dang it, focus. That's all I want. I moved the test twice for you guys. I just want you to focus and give like 1% of the effort that I do. Okay, that's all I want. I just want an ounce of effort and focus from you. That's all I want. Oh my gosh, let's do this one. So this is one of the things you have to, no, focus, come on. No tickety talk. This is one of the things you have to memorize. Sine inverse derivative and tangent inverse derivative. That's 4 or less than AB calc. There you go. 2 instead of 6. You only got to memorize these 2. Wonderful. So find the derivative. This should be like nice little cherry on top. 2 second. What's the derivative?
1 over the square root of 1.
Okay, girl. Good her.
Cool. There you go. There's the derivative. Boom. Find the equation of the tangent line at x equals 0. So we have
That's it?
the equation. Yes, this is it. Because I.
Wait, so why is this on a calculator?
I don't know. Why not?
I bet it
You
was
throw in some non-calculator problems in calc?
Of course, sometimes I'll throw in problems on the calculator section that you don't need a calculator for. But would you rather have it that way than like problems you need a calculator for and the
I
non?
need a calculator for the one
No, you
before
don't.
with the
No, you
12
don't.
times
No,
six.
you don't.
3.
Find the equation of the tangent line. So we have the equation. We have the equation of the slope. So first we have to find the slope as 0, then write the equation. So we're looking for the equation of the tangent line. Hint, hint. Your answer must be a line. An equation of a line. Okay. So I just have to plug in 0 in for x. So I get 1 over square root 1. You know what square root of 1 is. 1. Okay. So this is the slope. So this is my m, right? Slope is 1. What? I don't want to ban gum in here as well. Like, please don't. Okay. So I have my slope. I need an x value. Oh, that's 0. But the y value I'm going to plug in, we have to find what the y is. So let's plug it in to the original equation. What? The square root of 1 is 1. When it's given to you, you evaluate the root as if it's positive. If you're solving and you have to put the root, okay, what I mean, if you have x squared equals 9, there's a difference, right? I'm going to erase this after, just to be clear. If you have x squared versus 9 versus x equals root 9, if I give you the root like the right side, you evaluate if it's positive. Evaluate as if you're just given the positive root. On the left side, if you are solving for x and you have to put the square root to get rid of the square, you have to put the plus or minus. That's when you put plus or minus, when you are putting the square root to solve for x. If the root is given, you only evaluate if this is positive. Does that make sense? So, since I gave you the root, it's on your paper, you only evaluate the positive root. So, 1. Square root of 1 is 1. Yeah, that's true. Your calculator knows math, so. Yep. All right. Sine inverse of 0. Think about our unit circle. Where is sine equal to 0?
Oh, the answer is pi over 6.
Pi, 0 and pi.
Wait, let me look at
So, at 0 and at pi, this is where sine is equal to 0. But
Oh, you could just
But-
put it to your calculator.
But it's sine, but it's sine,
But
so you-
sine inverse. Inverse. And remember, inverse has a restricted domain from negative pi over 2 to pi over 2. So there's only one answer. So it's 0.
Just do sine negative 1.
So it's x is 0 and y is
Don't
0?
don't depend on that for your calculator, because when you do press a test mode, I can potentially.
No. You're so nice.
Because you should know this. This is a quadrantal angle. We went over in pre-cal last year. It's all good.
I don't know how you go backwards from it. Like,
So where is sine equal to 0? This is 1 comma 0. 1 comma 0. Sine corresponds to your y value on your unit circle. Sine corresponds to your y value on your unit circle. So I'm asking where is y equal to 0 on your unit circle? There's two places, 0 degrees and pi. So, but there's only one that's actually in the restriction for my inverse functions, which is going to be 0. Has to be between negative pi over 2 and pi over 2. So, one moment. Yes. Okay, if you're gonna be extra, I'm gonna skip you. Okay, so let me finish this problem. We'll come back. Think of a question. So I'm going to use point slope form. That's all I need. So I have y minus 0 equals the slope of 1 times x minus 0.
Isn't that just y equals x?
Yes. Questions?
That's.
I really want to get through this one. I'd like to get through this other example problem. I'd like to go through maybe some of the worksheet the other day.
Y minus 1.
Did you think of a question? Are you okay? I'm sorry if I was mean, but I just want to be like snappy, you know? Get through the stuff. Tissues, yeah. Are we done writing this down? We're done writing this down? Okay. Let's go.
So Brian, my sister, they almost had to cancel class for my sister.
Snow?
Yeah. It's so bad.
My senior year, it was 108 inches accumulation. I'm done. That was tangent. Here we go. A particle moves along. Yep, it was 2 seconds. A particle moves along the x-axis such that its position at any time t is greater or equal to 0 is x of t equals tan inverse of root t. Who cares about that stuff? All we care about, hey, look at this equation. Oh wait, what's that? We want the velocity at any time. Pause. What's the first thing? Okay, we have position equation. How do you find a velocity equation? Take the derivative. One more time.
Take the derivative.
One more time.
Take the derivative.
Oh, okay. Take the derivative. So v of t equals, what is the derivative of? Ooh.
1 over 1 plus x squared.
Plus x squared. I knew that one. So much.
Wait, isn't it the one where
No, you're not wrong. I realized I wrote really big. So, hold on. So that's for tangent, but this is tan inverse. Hold on. Pause. Okay. So, throwback. If I just had tan inverse of x, the derivative would be 1 over 1 plus x squared.
T squared of t squared, which is just t.
So, but, okay, you know how for ln, I showed you guys, like, if it's just x versus if you're taking ln of a function, we're taking tan inverse of a function, root t. So, if you have tan inverse of a function, you have 1 over 1 plus u squared times du dx. So, we're going to have to multiply by the derivative of, exactly, it literally is chain rule. That's what this is showing you right here, chain rule. You should just teach. Just take my job. Come teach calc. Okay.
I only know how to say change.
So u is a function. Yeah. So instead of just
function on its own, tan inverse 1 of x. Isn't that technically?
tan inverse. So okay. So tan inverse of x versus tan inverse of, here u is just standing for a function. So I could have it be tan inverse of x squared plus 5. Here in my actual, it's circled, I have tan inverse of root t. So when I'm taking the derivative, I'm going to have 1 over, 1 plus root t squared, and then I have to multiply by the derivative of t squared. I'm sorry, root t. What's the derivative of root t?
1/2. C to the negative 1/2.
Yes. But let's take a sec to make sure we understand what the heck we just did, because that's crazy.
The square root is 1 over 2.
So,
We're all really stressed honest over here, okay? So don't take it personally.
I didn't think that was mean. It was just like, she's the teacher.
Whew, whew. It's all, we're all good.
We chose
Okay.
other people. I just cry.
We're okay, we're good. So here, we don't just have tan inverse of x, we have tan inverse of a function. So remember how I was saying like u up in the right hand corner, right here, the u? Our u here, so I'm zooming in so you can actually read my handwriting. Our u here is t to the 1/2. So if I want u prime, aka du dx, one moment please. So du dx is the same as saying u prime. So you take the exponent, which is 1/2, bring it down, and subtract 1 from 1/2, so you get negative 1/2. This is the same thing as 1/2 times 1 over root t, aka it's 1 over 2 root t. Okay, I want to make sure we understand the part in pink I just did. Questions over this one?
Wait.
If you can zoom out.
Wow, okay.
Zoom out a little. Oh, that makes sense.
Okay. Okay, let's do one question at a time. Hannah.
Okay, answer the first part. Why did you do the 1/2 times 1 over root t?
So this is the power rule, right? You understand how you get the power rule?
Yeah.
Okay. So technically this is not just tan inverse of x, it's tan inverse of a function. Where here my function u is root t, which is t to the 1/2 power. So if you don't just have tan inverse of x, you have tan inverse of a function, you take 1 over 1 plus u squared, and then multiply by the derivative of the function.
Still a little lost.
Okay.
It's okay.
Wait, but you don't need to write it as 1 over 2. I mean, 1 over 2.
Like, could you just say half
times,
t?
not 2. Just leave it like that. Let's not get ourselves confused.
What's the question? What's the question?
Is it fine to just leave it times 1/2 times t to the negative 1/2?
This?
Yes.
It's not simplified.
No,
Oh, I get it. Okay.
It's not simplified. We gotta simplify it. Okay. So this is the same thing as 1 over 1 plus t times 1 over 2 root t.
Quick timeout.
Because, hold on. No need to laugh. So square root and square cancel out. And then this part was in pink on the left side. That's what this is equal to. So my final answer, I'll get to you in a moment. V of t, the velocity, is 1 over 1 plus t. It looks the same. 1 plus t times 2 root t.
Can we go over,
Maybe I should have changed. I should have made that in front. 2 root t times 1 plus t. And then if you want the velocity of the particle at t of 1, wait. We found the velocity equation for any point, any time. If we want time as 1, we literally take this equation and put in 1. 1 over 2 times root 1 times 1 plus 1. So I'm going to go back to Hannah's question. 1 over 2 times 2, so it's just 1/4. V of 1 equals 1/4. And we only have one question left. Woo. Okay, Hannah.
Okay. How do we get from here to here?
From what?
Here to here.
yeah. Good question.
So it's negative 1/2? Yeah. So, okay, so 1/2 power means square root. Right. So 1/2, so to the 1/2 power means square root. To the negative 1/2 power means 1 over the square root. And so if I'm doing 1/2 times 1 over 2 times 1 over root t, it's 1 over 2 times root t. Okay, other questions?
Oh my god, because it's negative root 2, which is
Okay, let's go on to the next one.
It's like when you're saying the word is Scottish, you made it like that.
It's relatable. It is. Yeah. Not to me, but to you. I don't.
Fine, okay, I did.
They do that?
Find the velocity.
It's like a Jewish. Not like a. It's
I know what a more Scottish is. I just don't know.
That's my favorite part.
Oh, I have a question.
Okay. Yes, about
This
this.
is a no, about like the test. Is it gonna be like this, just with different numbers?
I don't know.
Remember how you were
Really bold.
so nice?
That was
so bold.
Go off.
I don't know.
Wait, go back. Whoa.
What? Oh my gosh, I was even doing the sprinkler, talking about the Moore's Cottage, waiting for you to write.
What? Supposed to be talking Hebrew right now.
Low.
Wait, but you just wanted English and then you said
I know, yeah. It's pretty nice. Okay, number 20. Are we done number 20?
Yeah.
Yeah, this one should take 5 seconds. Let's do this. Sure.
Wow. Let the teacher explain.
Okay,
That was a good one. That's a good one.
Thank you.
I didn't hear it. I didn't hear it. Say it again.
No, you missed it.
Oh, okay.
Snooze, you lose.
You know what, I'll
Okay.
just speak now.
But actually, yeah. Okay, so, where is e to the x defined?
Oh, EDX.
All real numbers. It's defined for all real numbers. I could put in any x value into e to the x and
Let's kick her out.
stop talking. Just stop talking. That's all I want. Everyone stop talking. So, e to the x, you can plug in any x value and it gives you some. Why you look at her? I'm literally explaining a problem. Put in any number in for x and you'll get a y value. E to the x is defined continuous, all real numbers. The thing that's limiting us is ln of x. You don't have to put it in the calculator if you have like some intuition about basic math.
Bless you.
Where is ln of x defined?
1 over x.
Do we know what ln of x looks like? It looks like that. There's, so it's for 0 to infinity. 0 to infinity. You can't put in a negative number in for x, for ln of x.
Wait.
Hello.
This is the equation.
Guys, when you see this?
L.
have a calculator. You can just plug it.
Yeah, you could just plug it in, but then you're gonna be like, what the heck is this? Because it's not defined. It's not defined for any number less than 0. You can't put a negative in. You can't take ln of a negative number. So in your calculator, you might be confused because maybe you'll see what will it look like. It's smaller, same one. You know what? We should just look at it. Let's do it.
Will this function be restricted on our calculator? Can I just plug the entire thing in and do it that way?
You'll be able to like see it. Don't worry.
Stop laughing at me.
Not you.
Are you okay? Do you need a moment? If you need a moment, just step outside.
Are you crying too? I know it.
Okay, so after this, I'd like to do this problem that Hannah came up with, and then we can go over some of like the worksheet that you guys had last week. I just wanted you to do some work together. What? That would be great. Give me a moment. Let me put this in here. Okay, I'd like to graph e to the x times ln of x. I'd like to graph e to the x times ln of x. Cancel. I forgot that your calculator. You have to go to the special. Okay. E to the x times ln of x. So if you saw this, what would you think the domain would be?
Bracket 0.
Huh? 0 to infinity. I mean, we already saw the answer, but like, you might think negative infinity to positive infinity. Right, because you're like, I don't know, is it getting closer to 0, or is it like gonna go forever in the left direction? Like, who knows?
0.
So it's going from 0 to infinity. So it's not exactly clear with your calculator.
Can you do split graph and then see the table thing? That's what I do.
Also just do table.
Yeah.
Look at this. Errors.
Wait, but it also looks like the line that's not 0, it looks like it's ending at like 2. Like it looks like it's ending out.
Hold on. So you guys, my first graph. My bad. What?
Like the top part of the graph, it looks like it's going into a straight line. Is it not?
To the right part? To the right?
Yeah.
Yeah. But if you zoom out far enough, it will be like going that way.
Oh, I
It's just
see.
because e is an exponential function and it's increasing so much. And ln is positive. Like, so when you're multiplying a big number by a number larger than 1, it just keeps getting bigger and bigger. So you see it's like, oh, undefined here, defined here, so 0 to infinity. Yeah, you could do that. Okay, let's go on to other questions.
When you're multiplying to.
So the ln is literally not defined left of 0, right, for numbers less than 0. So that's limits, but we can actually plug in when I'm multiplying these two numbers.
Oh, so when you have
That's
two
why-
things next to each other, two different things that you can graph separately next to each other, if one is all
Well, if
real
you're multiplying
and
them-
one is limiting, you have to go by the whatever
Yeah.
is the limiting one.
Because
Okay.
you can't multiply e to the x by something that's undefined.
Okay.
Yeah. Okay, let's do this problem. It's a good problem. This is what we were talking about earlier. So we're trying to find the second derivative of this equation, cosine. Do you want it to be exactly like the previous problem, just one of them squared, or do you just want to be okay?
Make it a
Yeah.
little tricky.
Little, okay.
Make it exactly like what's going to be on the note.
No. X squared plus cosine squared y equals y. That's a nice try. X squared plus cosine squared y equals y. Okay, so we gotta take the derivative. So what's wrong? What are you doing? Talking smack? Ty.
Yeah, you're supposed to be the good one. That was a joke, sorry. Was that mean?
I'm not a good judge of that. Are you kidding me? No, I don't know. Okay.
You're like,
So
what?
Ryan,
And I'm like,
who's the good one?
No one. You know who it is? Tolly. She has never said one. I don't think she's listening.
What about Maya?
Were you listening?
Yeah, what about
Yeah.
Maya?
She talks so much smack.
Yeah.
Okay, here we go. Let's take the first derivative. First derivative. So 2x plus, so keep in mind, cosine squared y is the same thing as saying cosine of y squared. So if I want the derivative, you have to use chain rule. So it's going to be 2 times cosine y times the derivative of cosine is negative sine y times derivative of y is just y prime equals y prime. So it's very, very similar to a problem we already did. Yes.
Wait, what?
But this was the question she asked, what if it was like cosine squared y, not just cosine y? Because this is like number
I don't get why you
Why aren't you
live
doing
under
2x times
10, number 10. What?
Oh, so whenever you have a square,
Chain
you
rule.
just-
Use chain rule.
I don't get why you do next to negative sign y times. Like, I don't get the times y part.
Well, just to make things more fun,
Is it just like?
Oh, okay, hold on. Let me do one question at a time. So, for what? Do you have to go to the bathroom?
No, I'm
No. Okay, cool. So just a moment.
actually kind of.
So, I'm gonna answer her question first. Oh, this is always what happens in my classes. Someone's asking a question, then another person, can I go to the bathroom? Cool, you're gonna miss what we're saying. Okay. So, let's go step by step. Whatever. I mean, there's a whole like 45-minute lunch break.
Yeah,
There
but
had like
we
5
have
people up and leave
pictures
during
at
class.
lunch, So I got it.
Do you see the tear I'm crying for that? Okay.
See my tiny violin?
So I'm going step by step. First, we have to do chain rule. So the outside chain is 2 times what's inside. Cosine y. What? What are you doing? Pay attention. Pay attention. Then we have to take into account, we have this cosine function inside. So I have to do the derivative of cosine. Well, that's just negative sine.
Right.
Let me leave that part in green. Then inside of that, we have this y. Y is a function of x. So that's why I have to take the derivative of y. Derivative of y, 1 times, since it's a y, right, it's not x, we have to tack on a y prime. So it's literally 1 times y prime. So I'm trying to like visually with colors show the chain rule, how I start from the outside, went the way inside.
Do we have to write the one?
No. Did I write it first? No. I just want to make it clear. Okay. Does that answer your question? Okay. Yeah. Wait. What was your question? I
It's
so
about
lost.
the Y prime. But
And
you
it makes sense.
Yeah.
Okay, I was showing the chain. Okay, now you.
I just have a question. Why the top part? Oh wait, hold on. Why does this like go to that? Like
Why does what?
this?
So because cosine squared y is the same thing as cosine of y squared. So if you have
This?
cosine squared y, this is not the same thing as cosine of y squared. Cosine y squared is different. Cosine squared y is the same thing as cosine of y squared
Cosine of y.
times cosine y. The squared goes here, means you're squaring the whole thing.
Okay, so just know.
Yeah,
Okay.
you were expect. Oh, okay.
Bless you. If you don't expect it, come on. Come on.
Okay.
So if it was cosine of y squared, we would still do a little chain, right?
Cosine of y squared, yeah,
It'd be like
because
negative sine y squared minus
2y times y prime.
Oh, because that's another chain.
Yep. Whew.
Oh, because you pretend like there's just like a 1 exponent. That's the first chain.
Yep, that's why I wrote a 1 here originally. Oops. Okay, so let's finish out this problem. Wait, Tal, did I answer your question?
I know.
You know. Okay.
Oh, I did have a question. Well, I think I understand it.
Okay.
I have a question. Is that for the X? For the X.
So no question. Okay.
No, okay, for the
What?
X, we bring it down, I get that.
Yep.
But, like, wouldn't you normally take the derivative of X, but it's just 1? Is that why there's nothing here?
No, it's because we're taking the derivative with respect to x. So when I hit a y, that's not an x. So since I'm taking the derivative with respect to x, whenever I hit a y, I have to tack on whatever the derivative.
No, but
Of
wait,
y
let's
is
say you
with
had like
respect to
X cubed, you bring down 3x,
Yep.
and you just leave it with
3x squared. If you have x cubed, it's going to be 3x squared. You take the derivative as normal, but if you're taking the derivative of a y, you have to tack on a y prime.
Okay.
Okay, so I have a 2x plus 2 cosine y. Actually, it's going to be a negative because this guy right here,
So you guys do 2x minus
sine
2
y
sine
times y prime equals y prime. What?
Never mind, it's the same thing.
Okay, so, oops, I don't need the times. Times y prime. Okay, I need to get everything on the same side, so I have 2x equals y prime minus 2 cosine y, sine y, y prime. I need to pull out a y prime, it's a common factor.
Oh, but it's just one.
Wait a minute.
Yep,
Why did you choose to do the 2 by yourself?
because it doesn't have a y prime in it. I want all the terms of y prime on one side, everything without a y prime on the other, so I can pull out a common term of y prime to get it by itself. Yep. You know what? I'm not going to take the second derivative with this guy.
Oh, thank God. I was like,
This is some nasty stuff on the bottom. Yeah.
wait, you lost it.
I could ask you for the first derivative. That would be fine, but this is fine. That's the first derivative. What? Okay. What other questions do you have? Think about what other questions you have. Where do you think you'll mess up? No, I mean I'm being serious. Like, what part is the part that confuses you the most?
Okay, so velocity, you take, you do the
Derivative of position.
law minus s of 0 over law minus 0.
Oh, so average velocity.
Yeah,
It's a slope equation.
and then acceleration is just 1 prime. Oh, no. Instantaneous is 1 prime, and then
Instantaneous velocity is 1.
prime 2 prime.
So acceleration is the second derivative of position. Velocity is the first derivative. So I didn't grade these. I just wanted you guys to do them. But the solutions are online. I just wanted you guys to try this out. So look at these problems and see which ones you want to do. We have 8 more minutes.
Wait, I have a question. Only when it says average velocity, you use that, right? If it's just final velocity, you just do it.
Take the derivative. If it says average velocity, you use the
Do we ever use quotient rule? And if one?
If you have the quotient of 2.
Okay, what problem do you guys want to go over?
2.
I can tell you better than this. This class really works out. Yeah, let's go over 2.
What? Okay, let's go over number 2. All right, what's the first thing you think we should do?
Oh, this one, yeah. 'Cause it's quotient.
You can use quotient or you could use product rule. They both should work.
When I used product, I got a different answer for this one than my peers.
You said you get a different answer?
Yeah, but I might have been missed a change. Or done. I probably did.
So many random papers here. Did everyone get theirs back? Okay. Okay, I think I have everyone's here. Okay. I mean, you could move it to the top if you want to do product, or you could keep it below and do quotient. Well, let's show it doing both ways. So first we can do the product way. We should get the same answer. So I have x squared, I have y equals x squared times sine of 2x to the negative 1 power. So I'm going to let u equal x squared, so that means u prime is going to be 2x. I'll let v equal sine of 2x to negative 1 power, which means v prime, we have to use chain rule, negative 1 times sine of 2x to the negative 2. Times of chain rule. You have to take care of the negative 1 before you go through and do your, yeah. Before we go through and take care of derivative, so that was the outside with the negative 1 exponent. Then we got to deal with the derivative of sine is cosine, so cosine of 2x. And then we have to multiply by the derivative of 2x, which is just 2. So let me rewrite this as negative 2 cosine of 2x all over sine of 2x squared. That's really nasty, but it is what it is. Okay.
You say sine squared.
Wait, so
Sine squared, yeah, you could. I just don't want to confuse myself since there's like a 2 in front of the x.
See, that's not what you got.
What?
I mean, quotient.
What do you mean? Is this not the derivative of sine of 2x? It should be. You'll get the same answer. So we're going to do product first, and then if we have time, we'll go through and show how it's the same with quotient. Yes, Anna?
So just to clarify, product rule and quotient rule are interchangeable?
Well, I mean, I could rewrite. I rewrote.
Sorry, they're doing just.
I rewrote this whole thing like this.
Yeah.
So instead of having it a quotient of two things, I said it was a product, but one of my products is with a negative exponent.
So we can both know either way.
So I'm showing you how it's the same answer, whether we do product or quotient. Okay.
Isn't v prime just cosine 2x?
No. Because this is on the bottom of my fraction. When I'm doing product rule, I moved it up, so the exponent is everything to negative 1 power. Versus, if you're using quotient rule, the derivative will be a little different, but the quotient rule takes that into account. Okay, so y prime, u times v prime, so this is multiplied by negative 2 cosine 2x all over sine squared of 2x. I don't know if that confuses you. Plus, all right, so u, v prime plus v times, let's see, so v times u prime, so times 2x. Let's simplify this out. So this is going to be negative 2x squared cosine of 2x all over sine squared of 2x plus 2x over sine of 2x. I can simplify this. I see there's a common factor in both of these. So I can pull out a 2x over sine of 2x. See if this helps out. So this is going to be negative x cosine 2x plus 1. No, sorry. All over sine of 2x plus 1. Yeah. And then cosine over sine, that's just going to turn into cotangent. This is confusing. Do we see what I did? Right, the quotient rule makes it a little faster.
Why are you multiplying?
Multiplying what? I factored out a common term.
Oh, yeah.
Yeah. So 2x over sine of 2x times, let's see, negative x times cotangent of 2x plus 1. We're going to end up with the same answer. What did you guys get when you did it? You used quotient rule?
2x minus 2x squared cosine 2x.
Should we do quotient rule? I just wonder if we have enough time.
Quotient rule you did already, so we can go
No,
back
we did
to
product. This was product rule.
on the.
Oh, on the solutions? Okay.
I got this.
Thought I printed my solutions. I was just going to show you guys the same. Oh, so we do, okay, so we get the same answer. So I stopped at 2x sine 2x. 2x sine 2x. Minus 2x squared cosine 2x over sine squared 2x. Oh. So to make it look the same, at this point, all I'd have to do to make it look the same is make a common denominator. 2x squared cosine 2x. So multiply the right side by sine of 2x over sine of 2x. Is this what we get? This is what I get for the answer. On the other one, 2x sine 2x. 2x sine 2x. Yeah. This is the same thing. I didn't have to go back. I didn't have to go back and do this stuff. I didn't need to.
Thank you, Miss O'Brien.
All right. See you guys Thursday. It's the same answer for quotient.